Hi, this is Mr. Kieran. In this video, we're going to be looking at how you can determine how good someone else's measurements are just by looking at how they wrote them down. And that's called significant digits. So first of all, I just want to review how we make measurements if we're doing them ourselves. So the idea is whenever you're making a measurement, you record all the digits that are certain plus one estimated digit. And we looked at a few examples. So if I've got this pencil, I know it's going to be 2 for sure. That's my certain digit. And I estimate the last one, 0.9. And we talked about this having two significant digits. Both digits are good parts of the measurement. And we also talked about how the estimated digit could vary a little bit. It could be 2.8 or 2.9, as long as it's close to like reasonable limits. Now, what if we did this? What if we did an experiment like kind of like what we did, where you record the time it took for a pencil to drop from the desk to the floor? So we had 3 trials, 0.47, 0.54, and 0.42 seconds. And we wanted to do the average. So let's do the average. And we end up with 0.47666 on my calculator. Well, I can't record the average as 0.47666 because just by looking at this, you're going to see, wow, look at this measurement. Mr. Kieran is able to record the 246 decimal place, so the millionth of a second. That's not the case. I was only able to measure to the hundredth of a second. So this has to be reflected in my average. So when I properly record the time, I have to record it as 0.48. I have to do some rounding here. So I have to make this rounded and into 0.48 seconds. And that's the whole idea behind significant digits. You're kind of being careful to record the measurement the way it was originally done. So let's say we have a situation like this. You've got a bunch of friends that are bragging about the size of their TV. Friend number 1 says, hey, my TV is 300 centimeters large. Friend number 2 says, hey, my TV is 270 centimeters large. And finally, friend number 3 says, hey, my TV is 269.4. Well, who would you believe? Well, the first measurement here, 300, it's a kind of ambiguous. I'm not sure about these zeros. Maybe he measured it. He had exactly 300, or maybe he just guessed. We simply don't know. So because of that, I don't have a lot of faith in this measurement. I might only have faith in this first number and say this is only one significant digit in the measurement that I think. How about let's look at friend number 3. Now, friend number 3, they had this 269.4. Because they have a decimal place, you're probably thinking, hey, he or she must have used some kind of measuring tape, and they actually measured it fairly well. So I have a lot of confidence in this measurement, and I actually think that, hey, this 0.4 must be a good part of the measurement. So what we have here, we've got 4 significant digits. And that's kind of the idea behind analyzing a measurement made by somebody else. You look at how they wrote it down and look for little clues like that. So to do this, what we do is we have a series of rules, and these are called significant digit rules. Sometimes they're also called significant figures or sig figs. We're going to use significant digits. So the first we're going to do is we're going to assume that all non-zero digits, 1 to 9, are significant because you must have read it off of something, so we know that's a good part of the measurement. So if I've got 129, I'm thinking, hey, 1, 2, and 9, there are 3 significant digits here. How about 3.4? Well, you must have read it off some kind of device, so 3.4 has 2 significant digits. So this means we really have to be careful when we're dealing with zeros. Zeros could be problematic. Let's look at some examples. Well, what would happen if you have zeros between 1 to 9 digits? Well, let's look at this. So 4007. So if I'm measuring something and I can be confident in this last digit, everything else in between also must be a good part of the measurement. So these are called sandwich zeros. So what I have here, I've got the 4, the 7, and everything in between must be a good part of the measurement. So I've got 4 significant digits. Similarly over here, I've got this 0. It's sandwiched in between a 5 and a 4. So it must also be a good part of the measurement. So we've got 4 significant digits here. Okay, now let's look at these 2 electronic balances and let's look at the reading on them. So you notice the first electronic balance, my mass reading is 34.7 grams. My second one, this electronic balance is 34.700 grams. So basically just looking at this, you can say, hey, I'm recording to 3 decimal places. How do you know? Because I actually have values here. So these zeros must mean something. They're telling you that you can read extra decimal places. So these are called trailing zeros. They're found after the decimal place, right at the end. And they're always a good part of the measurement because they're indicating you can read extra decimal places simply. So all trailing zeros after a decimal place are considered significant. So for example, 100.0, I can read to the 10th of a centimeter. So I've got this, the one, the ones in between here, the zeros are sandwich rule ones, because if this is significant, the ones in between must be significant. So you got 4 significant digits. Here, I've got 1, 2, 3, and 4 significant digits as well. So these are called, again, trailing zeros. Now, how about scientific notation? Well, if you got scientific notation, everything is significant. So all of these digits here are good parts of the measurement automatically. And this is actually the best way to record your measurements if you really want to communicate the quality of them. Now, what happens when zeros are not significant? So there's a couple of situations. If the 0 is in front of the decimal place, like so, these are called leading zeros. Leading zeros are not significant. All they do is they move the decimal place over. So when you're looking at these measurements, I have 1 significant digit, 1 significant digit. Here I've got 1 and a trailing 0, so I got 2 significant digits. Now, other measurements are pretty more obvious in terms of the amount of significant digits. So for example, if I've got zeros at the end of whole numbers, they're ambiguous. We don't know if they're good parts of the measurement or not. So we assume that they're not good parts. We assume that they're not significant. So these zeros here at the end of these whole numbers are just pushing the decimal place in a way as well over. So these are all not good parts of the measurement. So here in my first example, I've got 1 significant digit. Here I've got 2 significant digits. And here I've got 1, 2, 3, and here's a sandwich rule 0. So 4 significant digits in this particular situation. And what we do with all of these rules, we use them to help us determine how good someone else's measurement is. So let's look at the rules that you have in your worksheet. So these are the same rules. They're just the ones that are found on your worksheet. So again, you can go through all the same examples we had earlier. The only thing I'd like to add is this sandwich rule idea here. Okay, if you want to add that in, that might help you a little bit. And one more thing we have to talk about, we also have to talk about quantities that are not measured. These are things like counted values or defined values. So for example, if you do 4 trials for a lab, you're counting. So 4 is a definite number. So it has an infinite number of significant digits. Similarly, if we've got a defined quantity, for example, we have exactly 100 centimeters in a meter, we also have an infinite number of significant digits in these numbers. So we don't limit calculations with the significant digits in these. So again, the rules only apply to true measurements. So what I'd like you to do is I'd like you to try these examples below and then pause the video and check your answers in a little bit. Okay, let's see how we did. So the first example, 3 significant digits. This one is 6. You have 2 sandwich rule zeros. Remember, zeros are the ones you have to worry about. This one has 2 significant digits, these two at the end. The zeros are ambiguous. We don't include them. This one has 5 significant digits. I have a sandwich rule 0 and a trailing 0 right at the end. Here, 4 significant digits with the sandwich rule. These 2 zeros are not, right? They're leading zeros. I don't include those, so only have 1 significant digit. Leading zeros, and then a sandwich rule 0 gives me 3 significant digits. Here I've got my leading 0 rule, 1, 2, 3, 4, so we don't include them. Then I've got some sandwich rule zeros, a trailing 0. So this one at the end has 1, 2, 3, 4, 5, 6, 7 significant digits. You get the idea. So do a little bit of practice. Significant digits are quite important because you really have to communicate how good your measurements are, and they're really important when you're doing calculations. So you round your final answers to the correct value. So that's it. Hope you enjoyed the video.